Hey learners, welcome to episode 7 of our Neet chemistry series for 2025 and 2026. I'm your mentor, Sir Chongtham David, and today we're diving into the fascinating world of coordination compounds, a high scoring topic that can give you real edge in the exam. We'll solve 45 carefully chosen questions to help you master key concepts like complex formation, isomerism, and bonding. Remember, just like ligands stabilize the central atom, your consistency and focus will stabilize your path to neat success. And remember, strong bonds create stable systems in chemistry and in your journey. Now, so let's strengthen those bonds and learn smarter together. Without further ado, let us dive into the questions. I'm going to share the screen for you. Okay, let us read the question. Question number 1. Says the compounds platinum tetraamino dichlorido platinum 2 bromide and tetraamino dibromido platinum 2 chloride constitutes a pair of A coordination isomers, B linkage isomers, C ionization isomers, D optical isomers. So these are basically formed by exchange of these ions, bromine and this chlorine. So they are going to constitute your ionization isomer. So option C is the correct answer for this question number 1. Let us see question number 2. Which of the following species is not expected to be a ligand? Ammonium ion will not be considered as the ligand. So B will be the answer to question number 2. Question number 3. In which of the following complexes of the cobalt atomic number 27 will the magnitude of crystal field stabilizing energy delta naught be the highest? In octahedral complex, the magnitude of this delta naught will be highest in a complex having strongest ligand. So out of the given ligands, cyanide is strongest. So delta naught will be highest for hexacyanido cobalt 3 ion. Thus, option A should be your answer. Let us read. See question number 4. Which of the following carbonyls will have the strongest carbon-oxygen bond? So, as you can see from the option, which of the following is likely to have the strongest carbon-oxygen bond? To answer this question, if you look carefully, as the positive charge on the central metal atom increases, the less readily the metal can donate electron density into the antibonding pi star orbital of CO ligand to weaken the carbon oxygen bond. So the carbon oxygen would be strongest in the case of manganese. The answer will be A. A is the answer to question number 4. Let us read question number 5. A square planar complex is formed by hybridization of which atomic orbitals? A square planar complex. So it is going to be formed by S, Px, Py, and dx square minus y square. So B will be the answer for question number 5. Question number 6. The type of isomerism present in pentamine nitrochromium 3 chloride is. What kind of isomerism it is likely to show? Pentamine nitrochromium 3 chloride. So it is going to show linkage isomerism. Question number 7. The silver plating of copper in this potassium salt is used instead of silver nitrate. The reason is in silver plating we use this coordination salt, potassium dicyanoargentate. It is used which provides constant and required energy supply for the formation of the silver ions. As this, okay, silver ion can be written as Cn2 minus after ionization of this potassium. So it becomes very stable, but if silver nitrate is used, the concentration of silver ion in the solution will be very large. In that case, silver will be deposited at a faster rate without any uniformity. So question number 7, the less availability of silver ion as copper cannot displace silver from this silver ion will be the answer to question number 7. Let us see question number 8. The spin only magnetic moment value of this chromium complex is, chromium ion in this hexacarbonyl complex of chromium, I can write CrCO6 is in what oxidation state? Zero oxidation state, right? And has what configuration? Atomic number of chromium. You can start counting from scandium, titanium, vanadium, chromium. Atomic number is 24. Likely the configuration using the inert gas configuration is argon 3d5 4s1. It has this electronic configuration. Chromium has this electronic configuration because it is in zero oxidation state. However, CO is a strong ligand. Hence, pairing up of electrons takes place, leading to following configuration in the chromium complex formed with carbonyl. So you can write this configuration. In the 3D, there are 5 orbitals. I can give you this picture of the 3D configuration. This pairing happens, because CO is a very strong field ligand. It pairs up the electrons in the D, which was initially present as singlet electrons. So this is the configuration. After hybridization takes place, it is the intermixing of orbitals to have equal energy. So this becomes a D2sp3 configuration. So since the complex has no unpaired electron, its magnetic moment should be 0. The 8 will be, the answer for question number 8 will be A, 0. I hope it is understood. Question number 9. Low spin complex of D6 cation in an octahedral field will have the following energy. You are given the options. You need to find the value of energy from the given options. So since this is a D6 cation in an octahedral complex, D6 having 6 electrons in the D orbital, this will be in the T2G set will be having 2 electron each. So I should write here 2, 2, 2. So all the six electrons are in the ground state, T2G. And in the EG, you have zero non-electrons because you have to distribute these electrons. So these are in the ground state, this is in the EG state. There is no electrons in the EG state, so we call it the low spin complex. And using the crystal field stabilizing energy formula, I hope you remember this formula. CSFE stands, sorry, it should be CFSE. Okay, CFSE stands for crystal field stabilizing energy. This can be written as negative 0.4 into 6 times the crystal field stabilizing energy in the octahedral complex, since it is given octahedral field plus the pairing energy. So if you input the value here, you are going to get minus zero point 0.4 into the 6 times of this delta naught value. I will shorten it. It gives your minus 12 by 5 delta naught plus 3p. So from the option, you can check it out. The answer will be B. Good. Let's read question number 10. An octahedral, an example of double salt is double salt. This is bleaching powder, calcium oxychloride. Then this is complex compound, a hyposalt, potassium must be the answer. You know the formula of potassium. It has the formula of potassium sulfate combined with another salt, a stable salt. So they share these two similar ions, and the water of crystallization will be 24. So this is your double salt. Potassium is the answer for question number 10. Let us also read question number 11. The ionization isomer of chromium complex is, you can write down, it will be, if you ionize this complex compound, it gives tetra aqua dichlorido chromium 2, chromium 3. So the answer for question number 11 will be option number B. Let us read question number 12. Question number 12 says, this given complex exhibits what kind of isomerism? Cobalt complex given to you with coordination number 6. So in the given compound, the compound may have linkage isomerism due to the presence of this nitro group, which may be in the form of either nitride or nitrate. Okay, nitrito, you call it, right? So it may have ionization isomerism due to the presence of two ionizable nitro and chlorido. It may have geometrical isomerism in the form of cis transform as follows, which I'm going to give you here. Cobalt, ammonium, you have nitro. Outside the coordination pair, another nitro group. And if I write this complex in this way, such that chloride and nitro group gets exchanged, I am going to obtain an ionization isomerism. NO2, here I can write NO2, close a bracket, Cl. See, this nitro group and this Cl group is interchanged. So this is a case of ionization isomerism. And I have told you before, this nitro can have either in the form of ONO or NO2. So this is the condition of linkage isomerism. And further, it can also exhibit geometrical isomerism, cis and trans. So possible isomerism are linkage due to the presence of this nitro group, ionization isomerism due to the interchange of this chlorine and nitro group, and geometrical isomerism in the fashion of cis and trans. So A will be the answer to question number 12. Moving on to question number 13, the IUPAC name of this potassium salt will be potassium. You can start giving the naming from the leftmost side. It starts from potassium. Then do the counting. How many coordination numbers present and how many, what type of ligands are present? Is it homoleptic or heteroleptic? So I think it is homoleptic. Only one particular type of ligand is present. So the name should start from the one present outside the coordination pair, that is potassium. So we'll name this complex compound. It is called potassium trioxalato. This is iridium, so we'll call it iridet 3 coming from this potassium. So when you check, the answer will be in option B. So name of this complex compound is called potassium trioxalato iridate 3. Next, question number 14. Consider the following complex. The coordination number, oxidation number, number of d electrons, and number of unpaired d electrons on the metal will be respectively. So you are given a question and it is asking you 5 types. So this is going to be a little bit lengthy. Coordination number, you can easily check from this given complex from the formula itself. It is 6. Okay, surrounding this central metal there are 6 ligands. Now you have coordination number. You can check and find out the oxidation number of this central metal, which is cobalt. How can you do this? Let us write the unknown oxidation number as X. To find the oxidation number of this, let us write oxidation number equals X is the oxidation number of cobalt. You know, amine is a neutral ligand, 5 into 0. Then carbonate. How many carbonate is present? 1. You know, carbonate has -2 charge, plus 1 into the ClO4 has -1 oxidation state, equal to 0. So when you solve this, X will be equals to plus 3. Okay. And the electronic configuration will be, for iridium, the electronic configuration will be, sorry, it's not iridium, it is cobalt. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt. Right after iron, cobalt comes. You know, the atomic number of iron is 26. Cobalt will be 27. The configuration will be 3D, 6, 4s, 0, because you are having oxidation state of plus 3. You're required to remove 3 electrons. Initially it was D7, it was 4s2. Removal of the 3 electrons now generates argon 3d6, 4s0 as the configuration. So far, how many questions you have attempted? Coordination number is 6, oxidation number is 3, number of d electrons will be how much? 6, right? And number of unpaired d electrons will be, all are going to be paired up because this is in the presence of a strong ligand. So 0. So now compare the options given to you from the question. So question number 14 will be option A. Okay. Coordination number is 6. Then the oxidation number is plus 3. D electrons is 6. Then number of unpaired electron is 0 because of strong field ligand. I hope it is understood. Let us read question number 15. Which of the following species represents the example of dsp2 hybridization? So find the hybridization of the central atom. As you can see, dsp2 hybridization. It cannot be exhibited by coordination number 6. So rule out, and this is not going to be shown. This will be shown by coordination number 4. So question number 15 answer will be option D, B, sorry, tetracyanonickel 2. Moving on to question number 16, let us read. When silver nitrate is added to a solution of a cobalt complex, the precipitate of silver chloride shows two ionizable chloride ions. What does it mean? So since the precipitate of silver chloride shows two ionizable chloride ion, the complex must have the structure such as, let me write it for you to have a better understanding. Cobalt complex given to you is, how to name this? So from this, you have to generate, because you know coordination number of cobalt is 6 NH3 5. So 1 chlorine and 2 must be outside the coordination pair. Now when you treat this complex with silver nitrate solution, the resultant or the by or the product will be CHCONH3 5 chlorine. Okay, and this nitro, 2 nitro will come here from the silver nitrate, and this 2 silver chloride ion will be formed. So now to balance this silver, you can write here 2. Hence 2 chlorine atoms satisfies the primary valency and 1 secondary valency. The 2 chlorine atoms satisfy primary valency and 1 secondary valency. 16 will be option A is the answer for question number 16. I hope it is understood. Let us read question number 17. The value of the spin-only magnetic moment for one of the following configuration is given 2.82 bm, which is in Bohr magneton. You can expand the value or formula of Bohr magneton. It is equal to EH by 4 pi m. The correct one is, according to the question, D5. You know, it is a very strong field ligand. So D5 means you have two sets. The degeneracy results in T2G and EG. 5 means there is one unpaired electrons in the T2G and none in the EG. So number of unpaired electrons, you can find it out. Let us say, since you have D5 and a strong field ligand, what is the condition? The condition is such that the T2G set will have only 5 electrons in such a way and none in the EG set. Clear? So magnetic moment should be equals to root over n plus 2. So there is only one unpaired electrons. If n equals to 1, the answer is root over 3, which is 1.732. You can expand in terms of Bohr magneton. Okay. Now in D3 complex, let us further analyze for D3 as well. Let me write at the bottom. D3 in a weak field ligand as well as in a strong field ligand. D3 should be in singlet form. So how many unpaired electrons? It is 3. So if n equals to 3, mu equals to how much? 3 plus 2, 5 3 is 15. What is root over 15? Root over 15 is 3.87. 3.87 will be the Bohr magneton, 3.87. And D4 in the weak field ligand, in such a way you can generate step by step. We have found out for D5. What about D3? We have just calculated that D3 will be root over 3.87. Am I right? 3.87. So same case you can also find for D4 configuration. In D4 configuration, the value of magnetic moment will be how many unpaired electrons in D4? 4, right? So mu equals to n plus 2. 6 4s are 24. The answer is 4.89 Bohr magneton. So far you have for D3, D4 and D5. So in the strong field ligand, this pairing will not take place. Okay. In the case of strong field ligand, the D4 configuration will have how many n values? Only 2. So mu will be equals to root over 2 into 4, which is root over 8. What is root over 8? 2.82. So from the given values of magnetic moment, compare and you can answer this question easily. So D4 in the strong field ligand has the maximum value of 4.89. So this will be the answer to question number 17. Clear? Question number 18. Consider the following complex ions P, Q, and R. P, you're given Q and R, salt of vanadium and iron. The correct order of the complex ion according to the spin-only magnetic moment values is. You have to arrange this in order of increasing or decreasing values. So the electronic configuration of central metal ion in the complex ions P, Q, and R. Let us say first consider P. If you write P, given to you is an iron complex. What is the oxidation state of iron here? Fe3 plus. So it must be in D5 configuration. 1, 2, 3, 4, 5. How many singlet electrons? You can justify 5. And next is Q, right? Q, you have vanadium complex. Hexa aqua. Vanadium 2 complex ion. So vanadium, scandium, titanium, vanadium, atomic number 23. From 23, you remove 2 electrons. You have the 3D configuration because you are removing electrons only from the 4s valence cell. So 1, 2, 3. So this is 3D configuration. And what about R? Let me write it here. R equals FeH2O6. So what is the oxidation state of this iron? Iron in Fe2 plus is 3D6 configuration. 1, 2, 3, 4. 3D6 configuration. Okay. So higher the number of unpaired electrons, higher will be the magnetic moment. So which one has the highest? P followed by R then Q. Thus the correct order of spin only magnetic moment will follow this string. Q, R, then P. So B, option B is the answer to question number 18. Moving on to question number 19. Which of the following is organometallic compound? Titanium compound is an organometallic compound due to titanium directly attached to carbon atom. So A for question number 19 is the answer. Let us also read question number 20. Which of the following statements is correct? Atomic number of nickel equals 25. Nickel is dimagnetic and nickel in tetrachloride, tetracyanide are paramagnetic or dimagnetic and paramagnetic. So to answer this question, you have to write down the configurations. If the number of unpaired electrons is 0, it will be dimagnetic. If there are some unpaired electrons, it is a condition of paramagnetic. So if you look at this nickel 2 plus, it is in D8 configuration. And in nickel tetrachloride, it has another 2 electrons. Number of unpaired electrons is still 2. But in tetracyanonickel 2 ion, after rearrangement, it has DsP2 configuration with 0 unpaired electrons. And nickel in carbonyl will have sp3 with 0 unpaired electrons, which is a condition of dimagnetism. So nickel in carbonyl, tetracarbonyl nickel and tetracyano, they are dimagnetic, and nickel tetrachloride is going to be paramagnetic because it has 2 unpaired electrons. B will be the answer for question number 20. 21. The order of the wavelength of absorption in the visible region is. So for any metal cation, the magnitude of this crystal field stabilizing energy delta naught depends upon the nature of ligand. Higher the value of delta naught, lower will be the wavelength absorbed. Delta naught is called crystal field stabilizing energy, or in short CFSE, which I have initially written. The value of this delta naught for ligands can be followed from the spectrochemical series, and particularly here the highest is nitrite, followed by ammonia, then the least is water. So wavelength will be varying in reverse order. The first one will be nitrite, ammonia, then the highest will be water. So do the comparison and tell the answer. A will be the answer because water has the highest wavelength because of least delta naught. The answer being higher the value of delta naught, lower will be the wavelength of absorption. Let us see question 22. The compound which is not colored is. So which do you think is not colored? So in this particular compound, if you can see in this option, Na2CdCl4, this cadmium has oxidation state of +2. So what happens? The configuration will be 4d10 4s0. All the 4d orbitals are fully or compactly filled. Hence, there will be no dd. Possible transition will be absent because if there is full electrons, there is no possibility of emission, that is excitation or de-excitation of electrons. And if there is no excitation of dd electrons or dd transition, the complex will be uh, it will have no color. So it is going to be called colorless. C is the answer to question number 22. Let us also see question number 23, which is not pi bonded complex. If you look at the options given, this tetraethyl lead PbC2H54 is not pi bonded. It is sigma bonded organometallic compound. Okay, Pb, you can write the formula C2H54. This is not the pi bonded complex. Rather, it is sigma bonded complex. Which of the following are inner orbital complex that is involving D2sp3 hybridization and is paramagnetic in nature? So this manganese salt, manganese complex ion, and this iron complex ion, to name, you can call it hexacyanido manganese 3, and iron you can name it as hexacyanido iron 3, same. They are inner orbital complexes and paramagnetic as well because it has lone pair of electrons. You know the condition of paramagnetic is it should have lone pair electrons, or you can say lone electrons. Lone electrons are not those electron which is not participating in bonding, as you have learned in the chemical bonding chapter. While this cobalt complex of oxalate is going to be dimagnetic in nature, it cannot be attracted by magnet because the magnetic domain is 0. There is no like magnetic domain. So 24, option C will be the answer to. C will be the answer to question number 24. I hope it is understood. Question number 25. Give the names of the complex. Give name of the complex. Name should specify the position of the ligands. So if you read this question, you have different types of naming here. Bis trans phosphine carbonyl chloroiridium 2. Usually the names of complex compounds are scary. It is very long and lengthy. You should be very careful in the nomenclature because for complex compounds, nomenclature is the most important part. If you don't know how to name the compound, you will not be able to understand the theory. It may be valence bond theory, Werner's coordination theory, or even crystal field theory. So, looking at this question, naming should be done alphabetically. Hence, carbonyl is followed by chloro, and then phosphine, bis used to denote two same groups, And trans, which we have learned in the geometrical isomer, it denotes the position of this carbonyl and phosphine as neutral ligands. And remember, only chloride is charged, -1. Hence, the oxidation state of this iridium will be in +1 only. Now, let us see the IUPAC name of the given complex. It will be called carbonyl chlorobis transphosphine iridium 1. Okay, I'll repeat again the name of the in the complex compound. It is called carbonyl chlorobis transphosphine iridium 1. C is the answer to question number 25. Question number 26. Which of the following coordination compounds would exhibit optical isomerism? The optical isomers are, pair of molecules which are not superimposable mirror image of each other. It may be your hand. When you clap your hands and see, you can easily distinguish that they are non-superimposable mirror image. The condition of optical isomerism or optical isomers are such that they are pair of molecules which are non-superimposable mirror image of each other. It can have in two racemic form or enantiomeric form. That is, if you call it enantiomers, it will be D form or L form. So the two optically active isomers are going to be called enantiomers. So if you want to write the structure, let us see. The answer for this question is 26 will be D. Because when you put a mirror in front of this tris ethylene diamine cobalt 3 bromide, this is the structure. Tris means 3. So put this compound in front of the mirror, you will generate, oh, there is no more space. Anyway, if you put this in front of the mirror, you are going to generate the D and the L form. The mirror image of this will form enantiomer. So this is your D form. We call it tris ethylene diamine cobalt 3 bromide. So they are enantiomers and they exhibit optical isomerism. Question number 27. An excess of silver nitrate is added to 100 ml of a 0.01 molar solution of dichlorotetraequachromium 3 chloride. The number of moles of silver chloride precipitated would be. You know the formula of molarity. It is number of moles of solid dissolved in liter of the solution. If it is given in centimeter cube, you have to convert it by dividing with 1000. And if it is given in terms of ml, same thing, because 1 ml equals to 1 centimeter cube, or 1 by 1000, because 1 part of 1000 is ml. Now, let us write the reaction to answer this question. The complex is dichlorotetraequachromium 3 chloride. The central atom, the metal ion should be chromium. The atomic number of chromium is 24. Water as a ligand have, okay, it is a neutral ligand, chromium being a metal with coordination number 6. It will take 2 chlorine, and outside the coordination pair you have chlorine. Now if this complex salt is treated with silver nitrate solution, the question is saying a precipitate is obtained. So what is the precipitate? It's already given to you in the question. Silver chloride is the precipitate in this particular reaction. So if this is precipitated, chlorine is substituted by nitrate. So the resultant product will be tetra aqua dichlorido chromium 3 nitrate. So you can find the molarity by using the equation. Molarity equals to weight by molar mass 1000 into volume. Weight by molar mass 1000, since sometimes questions can give you in terms of ml. Molarity is now equals to this weight by molar mass. If I separate this, it gives you a number of moles. So number of moles is equals to molarity into volume divided by 1000. So how much it is given to you? The molarity is 0.01. Right? If you observe the question, you will be getting the value of molarity. Volume is 100 ml. Simplify the equation. 100 and 1000 gets cancelled. 1 by 10 is 0.1. Multiplied with 0.01, the answer will be in terms of milli. 0.01 is option D. I hope the question is understood. Let us read question number 27. 28. The most stable complex among the following is it a potassium salt, platinum, silver, or potassium? You see potassium having EDTA with nickel. This is the answer for question number 20. The most stable complex, since you know EDTA, the full form of EDTA is hexadentate. It is a hexadentate and chelating in nature, and coordination number form will be 6. It chelates and coordinates from 6 sides, resulting in the most stable complex. So whenever chelation or chelating ligands are present, you should always check that the stability is usually the highest. So the most stable complex for question number 28 will be option D. Since the options are disappeared, I'll write it here, D. Question number 29. Let us read question 29. Which one of the following has the largest number of isomers? Iridium complex, cobalt, ruthenium, and cobalt, where R represents alkyl group, En stands for ethylene diamine. See, they are all isomers. Okay, which one of the following has the largest number of isomers? So if I write the isomers of this cobalt complex, I can generate, or ruthenium complex. Let us start one by one. Ruthenium complex. What are the possible isomers this can generate? You know, this can have cis and trans. Geometrical isomer is possible here in ruthenium complex. Whereas in this cobalt complex, none is possible. In the case of iridium, the cis and trans is possible. So either A or C, you have cis and trans, but no optical isomerism because it cannot form non-superimposable mirror image. But this cobalt complex having this 2 ethylene diamine and chlorine, 2 chlorine, it can form optical isomers apart from ability to form cis and trans isomer as well. So D can form both optical isomers as well as geometrical isomers. So the maximum possible isomer that can be exhibited by the complex will be 29. So the answer for 29 is option D. I hope it is understood. Question number 30. Which of the following statements related to crystal field splitting in octahedral coordination entity is incorrect? The x square minus y square and dz square orbitals has more energy as compared to dxy, dyz and dzx orbitals. Crystal field splitting energy delta naught depends directly on the charge of the metal ion and on the field produced by the ligand. In the presence of bromide as a ligand, the distribution of electron for D4 configuration and will be T2G3, that is 3 electrons in the T2G and 1 electron in the EG. D. In the presence of cyanide as a ligand, the crystal field stabilizing energy is less than the pairing energy. Question is asking which of the following statements related to CFSE is incorrect answer. So D is the incorrect answer for question number 30. The reason being cyanide is a strong field ligand and form low spin complexes. So for low spin complex, octahedral this crystal field stabilizing energy, octahedral crystal field stabilizing energy should be greater than the pairing energy. Clear? Let us read question number 31. Calculate the value of log K3 when the values of K2, K1, K4 and beta 4 respectively are given 2.0, 3.20, 4.0 and 11.1. You know, this beta means it stands for overall stability constant, or the product of the stepwise stability constant. Beta can be written as K1, K2, K3 multiplied with K4. Now take the logarithm of this equation. All this will change to plus log K1, log K2, log K3, log K4. Substitute the values, you can easily get the answer now. So log K1 is 11.9. Okay, the question is giving you 11.9 minus 3.20 when, okay, wait 1 second, when the value of log, calculate the value of log K. Okay, here you are supposed to find K3. Beta is given, so before log, when the values of log K1 is how much? 3.20. Log K2 is how much? 2.0. What about log K3? This you have to find, right? Now we're getting closer to the answer. Log K4, it is given 11.9. Correct. And beta log K4 is not 11.9, it is 4.0. 4.0. And right side you have the value of beta, that is 11.9. So from this you solve and you will get the answer for question number 31. Now let us do the maths. 11.9. So all these are transposed to the right side. Plus 2 plus 4. It gives 6. 7.20. 11.9 minus 7.20 will be 2.7. Yes. So 2.7 you have in option B. For question number 31, the correct answer will be option B. I hope it is understood. Let us read question number 32. Which of the following complex does not have a metal carbon bond? So this triethoxy aluminum has no carbon aluminum linkages. It is linked through oxygen. Okay, so three answer will be A, aluminum. Question number 33. In this pentacarbonyl complex of iron, the iron carbon bond possesses what kind of character? It possesses both this sigma and pi character due to some back bonding by sidewise overlapping between d orbitals of metal and p orbitals of carbon. The iron carbon bond has sigma and pi character. So answer will be option D. 34. The geometry of this tetracarbonyl nickel and this uh, nickel complex are both square planar, tetrahedral and square planar, both tetrahedral, none of this. Which is the correct answer? You find that from the hybridization value. The hybridization for the first complex, that is tetracarbonyl nickel, will be sp3. Same hybridization in the case of the second complex. You can call it triphenyl phosphine as the ligand, and chlorine is also present. So the geometry of these two nickel complex are going to be both are tetrahedral, because from the hybridization we have just concluded that they are sp3. So both must be tetrahedral. I hope it is understood. Let us see. Read question number 35. The crystal field splitting energy for octahedral and tetrahedral complexes is related as. The crystal field splitting in tetrahedral complex is lower than that in the case of octahedral complexes, and hence the relationship can be derived as such. Delta T, this is for tetrahedral complex with coordination number 4, is minus 4 times delta naught divided by 9. Answer for question number 35, it will be option B. Question number 36, match the column. The first column gives you nickel complex, chlorophyll, Ziegler-Natta catalyst, nickel, deoxyhemoglobin. So you pair this correctly. A, that is tetracyanonickel 2, will pair with DsP2 because this has hybridization DsP2, and dimagnetic because there is no lone pair of electrons around it. Chlorophyll will pair with manganese. It contains manganese ion. Ziegler-Natta catalyst is titanium salt. Tetranickel, tetrachlorido-nickel 2 ion will be sp3 character with paramagnetism. Deoxyhemoglobin is non-planar. So compare these values. You have A6, B4, C1, D2, and E3. A4, B, A6, B4 means A. A6, B4, C1, D2, E3. This is the answer for question 36. Question number 37. If the magnetic moment of manganese salt is for 5.9 Bohr magneton, predict the number of electrons. So magnetic moment can be calculated by the relation which I have initially told you before. Magnetic moment mu equals root over Nn plus 2 Bohr magneton, where N is the number of unpaired electrons. So the answer will be, you can see 5.9 you're given. You're asked to find N. Okay. So find this N, take the square root of this 5.9 into 5.9 equals to, if you go in this way, you are going to take a lot of time. So just take the nearest integer, 6 6 36, and n plus 2. Solve this, you will get a quadratic equation. Okay, so it is 36 equals to n square plus twice n. Let me bring up here, n square plus twice n minus 36 equals to 0. So what is the value for this n square? It can be either root over plus minus 25, which can be plus minus 5. So you have to take the positive value. 5 will be the answer for this question. Great. Question number 38. The correct structure of ethylene diamine tetraacetic acid EDTA is. The correct structure of EDTA. So this is a very basic question. Just know the structure, you can easily answer the question. So C will be the option for question 38. Moving on to question 39, the hypothetical complex chlorodiaquatriamine cobalt 3 chloride can be presented as by which of the following? So it can have this structure. From the name, you are asked to find the formula. So this is the formula for chloro. You have to go with the alphabetical order. Aqua comes first, then amine comes first, second, then Cl. As you can look from the observe from this compound, the formula will be COCl NH3 3H2O2. So naming should be done in such a way that the alphabetical order ligands comes first. As you can observe from this, the answer will be question number 39. Option is A. Moving on to the next question. Now we are left with just 6 questions. So bear with me. Which of the following is incorrect regarding spectrochemical series? Right, according to the spectrochemical series, this oxalate ion has much greater uh, strength as compared to fluoride. So this is incorrect. B, it will be, sorry, 40 will be option B. I hope this is understood. Let us read question number 41. Question number 41 says, which of the following is the limitation of CFT? Ligands are assumed as point charge. It does not account for the covalent character. It does not explain color formation. These are all basic points, the postulates you have to learn by heart. Okay, you don't have to think anything, but just remember the postulates. A1 and 2 will be the answer. These are the limitations. If it can explain the color compound because there can be excitation of the de-excitation of electrons from 1t to g set and eg set, the degeneration of the orbitals. Moving on to question number 42. For this complex formed by cobalt, this is an octahedral complex. What is the total number of metal carbon bonds and number of metal metal bonds? So what should be the nearest or the correct answer for this? You can definitely come to the conclusion or answer by drawing the structure. If you don't know how to draw the structure, it will be hard to answer the question. So carbon double bond oxygen, you have carbon, this is your cobalt, carbonyl, 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 and carbon double bond oxygen. Here you also have carbon double bond oxygen, carbonyl, carbonyl. So total metal carbon bonds will be 10. Okay, 10 is the correct answer, and metal metal bond is just one. Metal metal bond, you have this one. Okay, this is your metal metal bond. Right. Let us move on. Question number 43. It says which will give a white precipitate with silver nitrate in aqueous solution. So this platinum salt has chloride outside the coordination sphere. It can exchange with this nitrate and forms a white precipitate, silver chloride. So answer for this question will be 43. Question number 44. Nickel salt exhibits a temperature dependent magnetic behavior. The coordination geometries of nickel in the paramagnetic and diamagnetic states respectively are. So in both the states, paramagnetic and diamagnetic of the given complex, nickel exists as it can exist as Ni2 plus, which is the oxidation state whose electronic configuration will be then how much? Iron, cobalt, nickel, copper, zinc, right? That was the atomic number you have learned by heart in class 12. Now use that concept, atomic number 28, and removal of two electrons now will have what configuration? It will now have argon 3d8, 4s2 was present, two electrons. If it is removed, you have now 4s0. So in this, the paramagnetic state is observed, and the geometry of the complex is going to be sp3, giving a tetrahedral form of geometry. Clear? And the diamagnetic state is achieved by pairing of electrons in the 3d orbitals. Then there must be some pushing of the electrons and forming dsp2. Thus, the geometry of the complex will be dsp2, giving square planar complex. So answer for question number 44 will be C. As usual, you will try to solve this last question and give the answer in the comment section. We shall meet in the next episode. Happy learning and see you later. Thank you.